Hey guys, it's Mr. Win, and we're going to talk about operations with rational expressions again, but we're going to multiply and divide them, all right? So for these notes, our essential question will be, how do I multiply / divide rational expressions? All right? Now, one thing you got to know first are your restrictions. So I listed the steps to the side. You want to factor first, identify your restrictions, divide out common factors, and just simplify, all right? But we got to know what these restrictions are. So always remember, when you have fractions, okay? Fractions, you cannot divide by 0. You'll give you an error, right? It's not possible to divide by 0. So here, if I have 1 over x, right, this first example, if I have 1 over x, that means x cannot be 0, right? Because if x were 0, that means I'm dividing by 0, and that's not possible. Well, what about here? What if it's in x minus 3? Well, if it's minus 3, that means a positive 3 would make it 0, right? Because 3 minus 3 is 0. So our restriction here is also where x cannot be 3, okay? You got to know your restrictions when dealing with these. Right? It's especially important when you're trying to solve and you end up with one of these numbers, but it can't be that number, so it's not a possible solution, all right? So always know those are restrictions, okay? So let's look at an example. Let's actually multiply. So I have here two rational expressions being multiplied, right? So the first thing you want to do is factor. So it looks like our first part, x plus 3, that's factored, right? But look at the bottom. We got to factor that x squared plus 7x plus 6, okay? And this looks like a problem where we can use this little method here where we place these 6 on top, 7 on the bottom, and then we factor, right? What two numbers multiply to give you 6? But add up to 7, right? So what can we multiply? Well, 1 times 6. 1 plus 6 is also 7. So the bottom part here is going to be x plus 1 and x plus 6. And we'll leave x plus 3. Okay? All of that is going to be multiplied. Looks like the top side can be factored as well, right? Because 2x plus 2 can also be factored out as to 2x plus 1. I can factor the 2 out, correct? So this is where we check the numbers. Any x's I can divide out evenly. So here it'll just be 2x plus, and then 1 in parentheses. And the bottom part, we're doing another factor, right? We have 6 on top. So right here, 6. And then we'll put the 5 on the bottom. So what two numbers multiply to give you 6? But add up to 5. Well, if I multiply to 6, that's 1 times 6. That's not going to be 5. 2 times 3. Yeah, right. 2 times 3. So on the bottom will be x plus 2, x plus 3. All right. And now we got to identify our restrictions. So like I said, your denominators cannot be 0. Okay, so we're gonna figure out any of our factors on the bottom, which would make it 0. So here I have x plus 1, right? So we know here that x cannot be negative 1, because negative 1 plus 1 would be 0, right? Right here would be negative 6, because negative 6 plus 6 would be 0 as well, right? And if I check this one, 2, well, negative 2 would make that 0, negative 2 plus 2. And here, negative 3 plus 3 would be 0 as well. So those are my restrictions, right? These can't happen, right? So that's our step 2, okay? So we did the first step. We did the second step. And now let's figure out the third step. So let me use this in a different color just so we know we factored, define our restrictions. Now let's divide out the common factors. So if I rewrite everything, excuse me, you're multiplying them, right? So that means in fractions, you multiply the tops together, the numerators, and then you multiply the denominators together, right? So multiplying is just going to put everything together. X plus 3, and then a 2, and also an x plus 1, okay? All of that with the x plus 1, x plus 6, x plus 2, we're multiplying them all together. They all just land next to each other, okay? And now you want to divide out the common factors. So look for what's in the numerator and the denominator that are the same that could cancel out. Well, here's an x plus 1 and here's an x plus 1, right? They can cancel out. X plus 3 and x plus 3, those cancels out as well. So really all we're left with here is going to be, as your answer, 2 over x plus 6 and x plus 2. You do want to check step 4 if there's any simplifying that's going to be done, but here there's not. Okay, there's no that 2 can't be simplified, that can be divided with anything. We're just going to leave that alone. That will be your answer. All right, now let's look at dividing. All right, I listed the dividing steps too, but if you notice from multiplying and dividing, there are only 2 steps here that are new. We have to multiply the reciprocal, and we have to identify again the new restrictions, but the steps still stay the same. Factor, identify, and then these 2 steps, multiply by the reciprocal, identify new restrictions, and then divide out your common factors and simplify just like multiplying, right? So a couple of extra steps when dividing, right? But essentially we're kind of doing the same thing, right? And I'm going to show you how to do those 2 extra steps. So if I'm dividing, first step again is you want to factor it out. Factor it out all you can. So this top side, 5x squared and 10x, I could factor out a 5 because 5 divides into evenly, 5 and 10. And I can also factor out 1x, okay? Because at most they have 1x in common, right? So if I factor out 5x, actually divide it, 5 divided by 5 is 1, take out an x, factor an x, would just be left with x. 10 divided by 5 would be 2, take out an x, there's no x. Okay, so I can't factor out 5x. On the bottom, looks like a quadratic. I can use the little x here, right? So 1 goes on the top. And let me color code that again so we are all consistent. 1 here, and 2 goes on the bottom. So what 2 numbers multiply to give you 1 and add up to 2? 1 is easy, 1 times 1, right? So on the bottom is going to be x plus 1 and another x plus 1, right? Because 1 times 1 is 1, and 1 plus 1 adds down to 2. All right, let's factor the other side. 20x plus 40. Well, I can divide out a 20 from both numbers, right? 20 goes into both 20 and 4. And that's about it because the other ones don't have a variable. But 20, if I divide out 20 from x, leaves me with just x. If I divide 40 by 20, that leaves me with plus 2, okay? And then let's factor the bottom. X squared minus 1. 1 is a perfect square, okay? That's a perfect square, so our perfect square, our difference of squares, means that if I square root 1, it's just going to be 1. 1 and negative 1. Or sorry, excuse my cough, right? And now we have our division problem, right? Step 2, everything's factored. Now define your restrictions, okay? So here we're going to say x cannot equal, well, right here, it can't be negative 1, right? Because if it's negative 1 plus 1 would be 0. We don't want 0. Same thing here, right? Negative 1. Looks like this is negative 1 as well. And here, a positive 1. Okay, because positive 1 minus or plus a negative 1 was going to be 0 as well. We don't want that. So there's our new restrictions. All right? And the next step is to step 3. Multiply by your reciprocal. Okay? What that means is we're going to flip the second part, that second rational expression, and multiply like normal. So here, the first part stays the same. Okay? And then we're going to take the second part and flip it. So the numerator becomes the denominator, the denominator becomes the numerator, right? We're just flipping it and then multiply. So on the top is going to be x plus 1, x minus 1. The bottom is going to be now 20 and x plus 2. All right, go ahead and multiply. So when multiplying, they're all, together, right? So that would just now be 5x, x plus 2, x plus 1, x minus 1, all of that divided by x plus 1, x plus 1, 20, and x plus 2. All right, so here, before we divide out common factors, just like multiplying, we want to identify our new restrictions. Because I have a new fraction now, or I have a new rational expression. You want to figure out what can't be x as well. Well, negative 1 is still on there, right? Negative 1 is still on there. 20 is 20, but now here's a new factor, right? Here's a new factor. We can't be -2, so x cannot be -2 as well, all right? So we're going to add that to our list over here, -2. Just remember that. Now let's divide out the common factors. So step 4, just for clarity, I'm putting them in order. I'll just rewrite everything again. 5x. Okay. Just writing the problem again, and then we'll find out which factors that I can cancel. I can divide out evenly, and they'll just cancel each other. So here, right, there's an x plus 2 on top, and there's another x plus 2 on the bottom. Here's an x plus 1 and an x plus 1. X minus 1, x plus 1. Okay, we'll leave it. Now we divided out the common factors. So this is now going to be 5x, x minus 1, and x plus 1 with a 20. We'll just write the 20 up front so it will be clear here. Oops. Alright, I just wanted to grab this. Well, we'll just forget it for now. Alright, so then from here, we want to simplify. So step 5, we're going to simplify. Alright, that means just look at what I can divide evenly, whatever. Well, 5 divided by 20 here, right? We can divide that out. 5 goes into 24 times, so that would actually be a fraction of 1/4. And then we'll write our x minus 1, x plus 1. Oh, excuse me, that should be an x, right? 1/4, but with an x minus 1, x plus 1. And now everything's simplified. We checked our numbers, and then there we go. That's our answer. But just don't forget our restrictions. So I'm going to rewrite it again, just so we know that that's included as well, okay? So not only is that our answer, but those are our restrictions, right? They can't be those numbers. Same thing up here, right? We probably should have put our restrictions, so sorry we had to go back, but know that x cannot be -1, -6, -2, or -3. All right, and that's it. All right, thank you.